Good evening, students. Welcome to our learning channel of mathematics. In the last video, we covered operations, basic operations on mathematics, addition, multiplication, subtraction, and the fourth one, just I gave the hint how to perform division or quotient. Here we are going to use for division a non-zero square matrix. We can use quotient rule or division rule only for non-zero square matrix. Let us continue with that one. Before that, you should know to compute means find. To compute what I told that day, a power minus 1. It is called inverse. It is called inverse. Inverse of a. Inverse of a. It is also called as multiplicative inverse. There I took B inverse. So to explain how to find inverse of a square matrix, I am taking by default capital A. Multiplicative inverse. To compute inverse, these are things required. First one, determinant. Determinant of capital A. Number two, this is possible only for square matrices. I insist this one. A must be a square matrix. So to compute A inverse or multiplicative inverse of capital A must be a square matrix. Then how to compute determinant of A? That will continue very slowly so that it is a primary requirement to compute A inverse. Keep in mind, you can change the order also. A must be a square matrix. Only for square matrices, inverse is to be computed. And to find A inverse, the third one more is there. We are going to get here. These two play a vital role to get that A inverse called adjoint. Adjoint matrix of A. Simply it is also called as adjoint of A. Adjoint of A. So just I would like to give you an example how to compute determinant of a square matrix. Here we are going to get one more terminology called minor, M-I-N-O-R, minor of elements of square matrices. How to compute them, that plays a vital role here. Let us take one example, or I'll give you a general way of writing. Let capital A, I write the general meaning of the elements. First row, first element, already it is done. A12, A13, A21, A33. We must get a square matrix. These are the elements, 9 elements for a square matrix of order size 3 by 3. Now, first we have to compute minors, M-I-N-O-R-S, minus of elements. You can calculate minus for every element, 9 are there. For determinant, only 3 are required. If you know the method, the same thing is applied for remaining elements. So if you want to find out the minor for A11, we write m small m 11. What is the meaning? Minor of the element A11. You can write something, the bracket, which element you are computing. M11 of, it is not into. Because of this bracket, to avoid confusion, in some textbooks they write only M11. They won't show this. It is understood. M11 indicates it is the minor of this element. How to compute? You take vertical bars, not square brackets. One indicates delete first row, first column. If you delete first row and first column, leftover elements you have to copy. Leftover elements are A double two, A double three, two three, sorry, A three two, A three three. I'll show this one. Same technique you have to follow for remaining elements. You see here how I got this one. Deleting the first row and first column. These are leftover. That you have to copy here. AM11. Now what you must do here? Always you have to multiply first towards left hand side, then subtract the product. I'll show in dotted lines in this way. To find out the value of that vertical bars, it is called generally determinant. Determinant we can say of the square matrix element, determinant. Whenever you write two vertical bars, you will be getting 4, 6, 4, 9. We get a square matrix determinant there, always. So first you multiply these two, we get A double 2 into A23 minus these two, A32 into A23. So this is just a product. So the small correction, A22 into A33 minus A32 into A23. So just to focus on the subscripts and same logic you have to apply. For example, randomly select if I want to find uh, for 2 3 minor of 2 3, or simply we can write M23. I think what? Det of, you delete second row, second column. Second row, second column. Second row, third column. Second row, third column. Second row, third column. If you delete, left two elements are A11, A12, A31, A32. Second row, third column. The remaining elements you have to take in that det. Now, as usual, I told you how to get the value. First, you multiply towards left hand side and subtract the product of this side. What you get? A11 into A32 minus A31 into A12. Like that, you can calculate minus for every element. Hope you followed this idea. So let us continue. Here, I took a square matrix, capital A. Our target is to compute det A. We can write like this in vertical bars of that matrix A, square matrix, only for square matrices. Or we can write DET, small letters in brackets same, both are same. So for that, what you must do first? You highlight, you take any row or any column, not diagonal. You select either first row, second row, third row, your choice. First column, second column, third column, your choice. So I am taking row 1. Our selection is row 1. So here, because you are taking row 1, the elements position will be A11, A12, A13. You highlight those three. If you take row 2, A21, A22, A23. You want to select row 3, A31, A32, A33. Just you write on top or side like that. If you want to take column, same. C11, C first column, 11, A11, C11 you can take here, C1, C21, C31. Like that, you can take by default, easy to a computer, you take any row of your choice, but don't take diagonals. Don't take a diagonals. Only you have to select any row, any column of your choice. So right here, select any one row or one column. Here I took R1. Now det A, how to compute? Very simple. This one you should know. First row, first element, that is A11 into its minor. Just now in the previous lecture, I covered how to compute M11. This element into its minor. Then you follow alternative sign system. First plus, then we get negative. Next number, A12 into its minor. After minus, we get plus. Third element is A13 into its minor. This is a full to compute determinant. Now let us proceed. A11, 1. Use brackets along with the sign. M11, you have to use two vertical bars, vertical lines. M11 stands for minor of this element. How you get? Delete first row, first column. First row, first column, we are going to write down the leftover elements with proper spacing. Minus bracket A12, it is 2. 2. Next again, two vertical lines. We are finding here M12, minor of this element. Delete first row, second column. First row, second column. If you delete, leftover numbers are, or elements are 2, 1, negative 1, 0. Next plus, plus. A13, it is 1. A13 is 1. Again vertical bars. Delete. What is M13? Minor of this element. So how to get that minor? Delete first row, third column. First row, third column. Leftover elements are 2, 3, negative 1, 6. Just look at. I hope it is clear to you to compute the determinant. Short form det, it is called determinant of A. Determinant. N-A-N-T. Determinant of capital A. Because to find A inverse, inverse of a square matrix, is the first thing you should compute very carefully. Very carefully. And this value you should not get 0. You can get negative or positive. We take care that after computing this value, you should not get 0. You may get positive number or negative number because we are dividing with that det to get the inverse. It will be denominator. Division by 0 is not defined. For that sense, the value whatever we are going to get now should not be equal to 0. If it is equal to 0, we can write inverse is not defined or cannot be computed, cannot be found out. Let us continue. Now we shall compute this 1 as it is and this one. How to get? Already told you. First you have to multiply towards left hand side, then subtract this product. I will show dotted lines here to subtract. Right? So what you get here? Use square bracket here. 3 into 0. 3 into 0 minus 6 into 1. First step, you just enclose the elements in brackets. Later you can open it. Minus 2. Same. Again square bracket. Same ideology. First you multiply these two, then subtract the product these two. What do you get? 2 into 0 minus sign, then negative 1 into 1. This is over. Plus 1, again square bracket, same logic, 2 times 6 minus negative 1 times 3. Now open the brackets inside the square. This becomes 0 minus 6 minus 2 as it is, no change. Here also 0 minus minus plus, it is plus 1 plus 1 as it is. Here 2 into 6, 12 plus 3. This becomes 1 into negative 6 minus 2 into positive 1 plus 1 into 15. Last step, we get negative 6 minus 2 plus 15. That is equal to minus 8 plus 15. That is equal to 7. This is not equal to 0. Most important condition. The det value should not be 0. So here we can get the information A inverse exists. If you write the comment, if you are getting 0, A inverse does not exist. A inverse does not exist. So what is your det value of the given square matrix A? You have to compute like this very carefully because these are number oriented. So finally we write therefore det A, or we can write det of A is equal to 7. So to find the A inverse, because we are not getting 0 here, you make it positive or negative. If you get 0, A inverse does not exist. I write a note point here for idea's sake. Note. If det A value equal to 0, then A inverse does not exist. We cannot compute because we divide by this value. Because division is done with det A value. Be careful. If det A value is 0, division is not possible, not defined. Keeping in view that context, this value should not be 0. It may be positive or negative. Next, I'll continue with the second requirement called how to find adjoint of the matrix. If you know these two, then inverse is easy. You can able to compute. Students, in this video, you learned to find A inverse. What are the requirements? First one, A must be a square matrix. Second one, you have to find out its determinant, and the value should not be equal to 0 to find A inverse. Next video, I am going to cover how to find the third requirement, adjoint matrix of A. Once that is done, in the same video, we are going to compute A power minus 1 or A inverse with help of this det of A and adjoint of A. Meanwhile, so for a practice sake, I gave two examples on the board. So make a note of it. Compute det A and det B. Example 1, det A and det B. So you work out in the manner how I explained, so that the answers you can just give in the comment section. So do subscribe and share our channel to your beloved friends and their friends community, so that everybody will have subject knowledge in mathematics to tackle the problems. Keep learning always. God bless you all.